Good morning. We will continue the lecture series from the previous lecture. In the previous lecture, we have seen what is tensile stress, compressive stress, shear stress. I told a short form to remember a company name. Can you all remember that? Yes, it is Tata Consultancy Services. Let us go to the slide. Yes. What are the key mechanical properties that is to be understood? Let us understand the fundamental characteristics of materials. And the first property is toughness. So toughness is the ability of any material to absorb energy and plastically deform without fracturing, essential for impact resistance. Yes. So a guy is tough. So he is very tough. How he is very tough? When someone hits, he is not shattered. That is what toughness it means. So let us take a simple example. The two people are standing there, and there is a conversation between two people. And suddenly, the person who gets angry suddenly slaps the other person, and the other person does not move his cheek because he's a tough guy. Okay. So it is called an impact load, sudden load, which is happening. And the guy is having the ability to absorb the load and without any movement, that is not plastically deformed or fracturing his face. He was standing like this, like an army man, right? So this is about toughness. We will come across some common examples after discussing all the mechanical properties. And the second one is ductility. So the ability of the material to undergo significant plastic deformation before rupture, important for metal forming. So ductility is the ability of the material to undergo significant plastic deformation before the rupture. Like when we extend something, when we give a load, the material starts deforming and the length gets extended like rope. And without um, getting failure, the material regains its original position after the removal of load, that is elasticity. And if it is permanently getting deformed, but without any fracture, that we call it as ductility. Okay. So we have two strengths, that is ultimate tensile strength and yield strength. And the yield strength is the stress at which a material begins to deform plastically, indicating the limit of elastic behavior. So ultimate tensile strength is the maximum stress a material can withstand before failure, crucial for design safety. And we will see live examples in our daily life so that we can understand better about these properties. So toughness, when you carry a load in your shop floor or in your home, suddenly if there is a slip of the material from your shoulder or from your head, what will happen? The material suddenly gets dropped into the floor without intimating that there is a load that is going to hit the floor. So that is when if the tiles gets broken, then the material is not tough. If the tile exerts a resistant force that there is no failure of tile, then we call this material is tough. Okay. So ductility, you all know, wearing a gold chain. All people are very fond of gold, right? So ornaments. So all the ornaments are prepared from the gold, from the bar we are getting. The bar is being subjected to many rolls. So the ability of the material to drawn into wires. So all the gold biscuits are being drawn into wires and it is being compiled into different ornament designs, and we are getting a bracelet and we are getting a chain, so many things, right? I think you all know, you understood what is ductility. And let us talk about ultimate tensile strength. What is this ultimate tensile strength? So it is the maximum stress a material can withstand before failure. It is crucial for design safety, right? So everyone will have the ultimate um, potential, right? Beyond which they will fail, beyond which the material will fail. Let us take a simple example of brittle materials. You all have had biscuits, right? So you take a biscuit and you start applying a load in the biscuit on the two ends with your hands. So when you start applying the load or giving the force, the biscuit suddenly breaks, right? Because it has crossed its maximum tensile strength that it can withstand. Okay. So if it suddenly breaks, what will happen? There is a safety issue of the particular design. Okay. So we always ensure that the maximum stress or the working stress is always below the maximum stress so that the material doesn't get failed. Okay. And we have several points of stress strain curve. Whenever the material is loaded, it starts with an elastic region and it goes to the yield point and plastic region. Then there is a fracture point and the material gets failed at the fracture point. So let us see one by one. The elastic region is where materials can return to their original shape after the load is removed. At the yield point, the material begins to deform permanently and do not return to their original shape. In the plastic region, the materials undergo deformation permanently without returning to the original shape. Then the fracture point is where the material ultimately fails and breaks under stress. Okay. So the importance of stress strain curve is you can understand the material behavior, aiding in material selection and engineering design. Okay. So I think we have done with the topic today. We just learned what is the different material properties and what are the different regions of stress strain curve. Thank you all.